Now let us study the intersection of a line and a circle. Now we consider a simplest case, that is if we are given a standard circle, that is having the equation as x square plus y square equal to r square, and some general line, say y is equal to mx plus c. Then we know that there can be three possibilities, that is a line may not touch or intersect the circle, or it may touch the circle, in which case we call it as a tangent, or it may intersect the circle, in which we call it as a secant, right? So to find out what is the actual situation, we solve the two equations simultaneously. That is, in place of y in the equation of the circle, we substitute the expression for the line, that is mx plus c. So that is where we get x square plus mx plus c the whole square equal to r square. So on solving that, we get a quadratic equation in x square. Now being a quadratic, there are three possibilities about its discriminant. If the delta is less than 0, that means there are no real roots of the quadratic equation. That means the circle and line have no point in common. So that means it indicates this first case, that is delta is less than 0. Correct? Now if delta is equal to 0, then that means the roots are real and equal or identical. So what it means is the line basically represents the tangent. So this is the way to get the condition of tangency, which we'll see shortly. And the third possibility is that if delta is greater than 0, then we get two real and distinct roots. So what it means is the line cuts the circle in two distinct points. Correct? So that is where the third possibility comes into picture. Correct? Now let us focus more on the tangency, that is the condition for tangency. So that is where we start off with delta equal to 0 and develop a simple condition which we can use as a test to check whether a line is a tangent to a given circle. So this is where we find out the condition for tangency. So let's consider once again a standard circle and some line y is equal to mx plus c. So as we have seen earlier, delta equal to 0 in the quadratic equation that we obtained earlier. Putting the values of the respective coefficients and simplifying, we get the final condition as c should be equal to plus or minus r root of 1 plus m square. So that means if we know the slope of the line and the y-intercept, that is from its equation, and if we know the radius of the circle, since that will be given to us, so we can detect whether a given line is a tangent to the circle or not based on the condition obtained here. Now why we have plus or minus sign at the end, or what is the significance of that? So what it means is, like, there can be two possibilities of the tangents having the same slope. So that means for a given slope, the constant term can vary, which will make the location of the line, tangent line, parallel to itself at the other end of the circle. So let us solve one sum based on this condition of tangency. If the line y equal to 2x plus c is a tangent to the circle x square plus y square equal to 9, then find the value of c. Now from the equation of the line, it is clear that the slope m is 2, and from the equation of the circle, it is clear that the radius is nothing but 3, because 9 is 3 square, and we have to find the c. We have just seen that c has to be equal to plus or minus r into root of 1 plus m square. So therefore it should be plus or minus r is 3 into root of 1 plus 2 square. So therefore c turns out to be plus or minus 3 root 5. So if c has either of these two values, only then the line will be tangent to the given circle.